everyone, good morning. Ma'am Priya Jolly here again, back with the first chapter, Chemical Reactions and Equations. In the previous video I told you about the two types of chemical reaction, that is combination reaction and the decomposition reaction. Today we are going to do the displacement reaction, double displacement reactions and redox reactions. So we'll start with the first one, that is displacement reactions. Right? Displacement, as the name indicates, to displace something, to remove something from its place. Right? So that is known as displacement reaction. Now in displacement reaction, what happens? The more reactive metal displaces the less reactive metal. And how will you come to know which one is more reactive, which one is less reactive? For that, children, you have to learn the metal reactivity series. This is a must. You have to learn it. This is going to help you in your further studies also, in the further chapters also. Right? So, metal reactivity series, first comes potassium. We start with the most reactive metal to the least one. So, potassium, then sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. Right? Then in between comes hydrogen. Although hydrogen is not a metal, but we place it in the metal reactivity series, and why we do so, that will take up further afterwards. After that comes the least reactive metals, that is copper, mercury, silver and gold. So you have to learn this series, and a very easy way of learning this is just remember this name, Professor S.C. Mazetel. Professor, that is P for potassium. Then S for sodium, C for calcium, M stands for magnesium, aluminium, then comes zinc, iron, tin and lead. So if you remember this name, you can learn it very easily. Right? Then comes this copper, mercury, silver and gold. So to know the displacement reaction, you have to first learn this. Now we take this example. Suppose we take iron nails and put them in a solution of copper sulfate. Now copper sulfate, you know, it is blue in color. Now this iron nails, they are of steel color, that is grey color you can say. Now if we place these iron nails in a solution of copper sulfate for some time, say 20 minutes, 30 minutes, after that what we'll observe, it forms a solution of FeSO4 plus copper. Now this FeSO4, what happens is, this iron metal, it is more reactive than copper. Can you see here? Iron is here, copper is here. So this most reactive metal, it will displace copper from its place and take its place. It will form FeSO4 and copper will be left out, right? So it turns, this solution which was blue in color, it turns into pale green color. And on the iron nails, we see a brown coating. Like otherwise also, you must have seen, if you put iron outside, it gets a rusty coating on itself. So here also what happens? Iron nails, they get a coating of brown color over it, and the solution of copper sulfate, it turns to pale green color. Same way, we can take another example also, like if we take zinc. Zinc is above iron. If we take zinc in a solution of copper sulfate, now the zinc, it is silver in color. copper sulfate, blue in color. Now what will happen? Zinc is, again, here you can see zinc is more reactive than copper. So what will it do? It will displace copper and take its place. It will form zinc sulfate plus copper. And on the zinc sulfate, we'll see bronze coating. Right? So the color also changes. Now you have to remember these colors because they are asked in exam. Specifically, they are asked in exam. What is the color change? Right? So this is known as displacement reaction, in which more reactive metals, they try to displace the less reactive metals. Same way, on the other one, if we see, now in this sometimes what is done in exams, they ask like this also. What will happen if we put copper in iron sulfate solution? What will you do? Immediately the children will write, yes, it will form copper sulfate plus iron will be displaced. You will get a big 0 on this. Why? Because copper is less reactive metal. It will not be able to displace iron. So in such type of reactions, what you have to write? No reaction will take place. So for that it is a must that you should know this series. Otherwise you will make this mistake. Right? Now, in double displacement reaction, this is single displacement reaction in which one metal, it tries to displace the other metal from the salt solution. In double displacement reaction, what happens? There are two salts like BaCl2, very common example of this is barium chloride, plus sodium sulfate solution. What will happen now? Now here exchange of ions take place. As I told you that how to write the reactions, how to form the products, right? And I told you that when they are in the solution form, they will try to break up into ions. So here the exchange of ions will take place. What will happen? This positive ion, it will combine with the negative ion here and form BaSO4 plus what will be formed? NaCl. I'm not writing the balanced equations here. You can balance them, right? So here what will happen? Exchange of ions will take place. That is why it is known as double displacement. One example we took in the first video, that was of we took lead nitrate plus potassium iodide. Right? Here also it will break down into ion form, and what will it form? It will form PbI2 plus KNO3. This is also an example of double displacement reaction where two salts, they combine together, they break up into ions, and the exchange of ions take place. Right? Here also lead, it is positive ion, it will react with the negative ion this side. And here this is positive, this is negative. So they both will form a salt together. Right? So this is known as double displacement reaction. Next is the redox reaction, a very important one indeed. Now what is this redox reaction? Redox, it is formed by two words, right? Redox reaction. R-E-D. This stands for reduction. And OX stands for oxidation. That means in this reaction, oxidation also is taking place plus reduction is also taking place. Oxidation, commonly when we say what is oxidation, it is addition of oxygen to any substance. That is known as oxidation. Like if we take copper. We take copper in a china dish and we take copper here, which is brown, reddish brown in color. Right? And we start heating it. Right? We heat it. What will happen when we heat it? This color, on the surface, a black coating will be formed. Right? This will turn into black color. Why it turns into black color? Because copper, when it is heated in the presence of oxygen, it forms copper oxide. Right? So, what is being done in this? Oxygen is added to copper. So, it gets oxidized to copper oxide. Right? Now, this, if in this copper oxide, we pass hydrogen over it. When we pass hydrogen over it, it will form, now you know that Cu plus H2O will form, H2 plus O will form water. Right? So again copper will be formed. Again the reverse reaction will take place and this will turn into brown color. Now in this what is happening? Here copper oxide, from here oxygen is removed. Right? It turns into copper only. And to H2, O will be added. So it forms water. So what is taking place here? Reduction. What is taking place here? Oxidation. So what is oxidation and what is reduction? Oxidation means adding of oxygen. Right? Here oxygen is added. In reduction, what is happening? Oxygen is removed. There is one more definition for this. That is just the opposite of here. If hydrogen is removed, then also it is known as oxidation. And if hydrogen is added, then it is known as reduction. Just the opposite. Like just now we did this example. CuO plus H2 gives Cu plus H2O. Now in this, what is happening on the reactant side? We have to see what is happening on the reactant side. What product is it giving? CuO is being reduced to Cu. H2 is being oxidized to H2O. So what will we write? CuO is reduced, then H2 is oxidized. We don't write from this side. We always write from the reactant side. Another term that we use is oxidizing agent and reducing agent. Now in this case, what is the oxidizing agent? This copper oxide is oxidizing agent. It is helping hydrogen to get oxidized. So copper oxide becomes the oxidizing agent. The one which is reduced, that becomes the oxidizing agent. And hydrogen here is being oxidized. It is reducing copper oxide to copper. So this becomes the reducing agent. The one which is reduced becomes the oxidizing agent. The one which is oxidized becomes the reducing agent. Now one more example of this we'll take, where I was talking about this hydrogen. We'll take one example of this also, like if you take MnO2 plus HCl, it will form MnCl2 plus H2O plus Cl2. Right? Here we will see from MnO2 oxygen is removed. Right? So this becomes this gets reduced. And from HCl, what we just now I said, we have to see the reactant side. From HCl, what is happening? Hydrogen is getting removed and only chlorine is left. From HCl, only chlorine is left. So from HCl, H is being removed. Minus H2O. H2 means if it is minus, it is being oxidized. So here MnO2 is reduced, this becomes the oxidizing agent. HCl is oxidized, this becomes the reducing agent. Right? So this is how the redox reaction takes place. Now this oxidation, it plays a very important role in our everyday life also. You must have seen, if we leave some iron objects outside in the atmosphere, we leave them as such. After a few days, we see that they get rusted. Same way, some other metals also, that is corrosion, takes place. Some other metals also get tarnished, get corroded if we leave them out, like silver. Silver, it will take or it will react with hydrogen sulfide present in the atmosphere and form Ag2S plus H2. This silver sulfide, this is black in color. That is why if we leave silver articles outside, they turn a little black in color. Same way, if we leave copper vessels outside, what will happen? This copper, it reacts with carbon dioxide in the atmosphere plus the moisture which is present in the atmosphere, and it will form basic copper carbonate, that is CuCO3 point CuOH whole twice. This is known as basic copper carbonate. So this process is known as corrosion. When the metals get corroded, they get rusted, they get tarnished, that is known as corrosion. Layer by layer, the metals, they slowly starts getting eaten up. So this slowly eating up of the metals, that is known as corrosion. It can be by air, by the reaction of acid, right, anything. So that is known as corrosion. Now there is one more process of oxidation which plays a very important role in our daily life, that is rancidity. One is corrosion, the other is rancidity. Now what is rancidity? Rancidity is when the oily substances, the fatty substances, they are oxidized, they come in contact with oxygen, what happens? Their smell changes. Right? There's a foul smell. The color changes sometimes. Like if you keep any namkeen or any oily substance outside, the smell will start coming from it. Right? The taste will change. That process is known as rancidity. How can we prevent it? By adding antioxidants or keeping them in the airtight containers. That will prevent the oily substances from getting rancid. Right? You must have seen the chips that you eat. The packets are very fluffy. When you open them, the gas is released out. That is, they are filled with nitrogen gas because it is inert. It will not react with any food substance which is present inside. But it will prevent it from getting rancid, from coming in direct contact with the air. So with this, children, we finished this chapter. This chapter is over. We'll start with the other chapter next time now. And as usual, if you have liked my video, please like my video, share it, subscribe it, and you can comment in the box given below. Right? Thank you so much.